In this video, I will be talking about linear equations. Specifically, we're going to talk about what linear means, why 2 points determine a line, and we're going to talk about the specific equation we call y equals mx plus b. And we're going to understand the concept of slope, what slope means, and then we're going to understand the formula for finding the equation of a line given 2 points and 1 point and a slope. And then we're gonna know how to find lines parallel and perpendicular to a given line, and we're gonna understand some of the applications. So that's the summary of this video. Alright, so in mathematics, the simplest model for relating two variables is what we call linear equation in two variables, y equals mx plus b. So y equals mx plus b. So when we say two variables, we mean x and y. So variables here are x and y. And although m and b looks like a variable, these in mathematics are what we call parameters. So these are generally fixed numbers. So these are parameters, and generally they are fixed numbers or quantities. So this is a general form to represent linear equation. The equation is called linear because the graph of an equation like this always looks like a line. So y equals mx plus b, any type of equation like this is always going to represent a line. So in this equation, by letting x equals 0, we get something like y equals m times 0 plus b. So we get y equals b. And you may remember replacing x with 0 basically leads us to find y-intercept. So what that means is that then this y equals b is actually the y-coordinate of the y-intercept. So 0 comma b. So for that reason, b is always going to be the y-intercept of this y-intercept of equations like this. All right, so now we move on to the next page. So we know that y equals mx plus b, when we look at the first graph, we'll realize that b, 0 comma b is always the y-intercept, whatever this point is. And then we have some situations where a line seems to be rising. In this case, on the left, it rises. On the right, you can see that the line falls. And so what that means is that we have different types of slope. And we're going to talk a little bit about what we mean by that. So what we mean is this following. So we always treat m to be the slope. So what slope represents is slope represents the change. So slope is the change in y when x increases by 1. So every 1 unit increase or change in x results in how much change in y. So that's the idea of slope. You may have heard different definitions and descriptions for slope, but the basic idea is always the same. For 1 unit change in x, how much does the y change? So here, m changes positively, it increases. Here on the right side, you guys realize for every change in x, for every 1 unit change in x, y decreases. So for that reason, we have a negative slope. So we're going to note here, this is a negative slope. On the right hand side, we have positive slope. All right, so what is m? It is the slope, but why? So we're going to use this table of values for a given linear equation, y equals negative 3x plus 7. So you guys realize on this table, we look at x and y values. Specifically realize that x values, so we look at the change in x values. So going from here to here, I'm going to use this one. from -2 to -1, -1 to 0, 0 to 1, 1 to 2, you guys realize each time x seems to be increasing by 1. Let's take a look at y and see what happens to y value when we change y value. So from 13 to 10, you guys realize we decreased by 3, 10 to 7, decreased by 3, 7 to 4, 4 to 1. You guys realize each time y seems to be decreasing by 3. So what that means is that x increases by 1, y decreases by 3. So this means that the slope of this line is actually -3. And so that's the idea behind slope. Again, for every 1 unit increase in x results in a change in y, and that change is actually your slope. So summary, the y-intercept is 0, b. So this is the point notation that we recommend you use. Point notation. Because this is almost like x, y. X is 0, y is b. And then the steepness or the slope of a line is m, which is always represented as m times x. For example, the slope of y equals 5x minus 15 is always 5. So the slope of this line is always 5. And the y-intercept, b is -15. So the y-intercept as a point will look like 0, -15. Next, we move on to this idea of vertical lines. So we know that vertical lines in general literally look like vertical lines. They have the equation x equals a. So the way we get that is we know that generally linear equations look like y equals mx plus b. So you guys realize this line basically has we cannot write it this way because it does not have a slope. So slope of this line is undefined. The reason is that we cannot do a change in x. So x seems to be always the same. So x, no change in x. So for that reason, we cannot compute a slope. So for that reason, we're gonna say vertical lines always look like x equals a. So it's always gonna be a constant x value. So you guys realize on the example on the graph, you'll see 3.1, 3, 5, 3, 5. These points are on the vertical line, and they all have the same x but different y values. So generally speaking, vertical lines are represented as some value x equals a. Horizontal lines. You guys realize we can actually compute slope for these horizontal lines. So every change in x, you guys realize, so like 1 unit change in x results in 0 change in y. So like, for instance, going from here, this point to this point, you guys realize x changes by 1. So x is going +1. But then you guys realize y value is just the same. There is no change in y value. So for that reason, slope has to be 0. So these types of lines always have the slope 0. The way we represent that is we use the general form mx plus b. Replace slope by 0, so you always get y equals b. So what that means is that any equation that you see that looks like y equals some value, then it's always going to be a horizontal line. For instance, in the graph, we have y equals 2. All right, next we talk about an example. So x plus y equals 2. So you guys realize this does not look like y equals mx plus b, right? Because realize all the variables x and y are on the left side, and then a constant is on the right side. So it does not look like mx plus b. What we can do is actually we can make it look like y equals mx plus b. And one thing we know about this equation mx plus b is that y, it's like y is isolated, right? So y is always on the left side and isolated. So why don't we try to isolate y in the equation x plus y equals 2? So for that, what we will do is we'll move the x to the right hand side, so subtract x from the both sides, and then we'll get something like y equals 2 minus x. So we'll reorganize this a little bit. Y equals negative x plus 2, right? So I'm just gonna reorder 2 and negative x. So 2, because 2 is positive, I'm just gonna say negative x plus 2. So then what we'll notice here is now this guy, if you modify negative 1, so here because x is negative, I can make it look like y equals negative 1 times x plus 2. So you guys realize this actually looks like the form that I know, mx plus b. So what I know about this now is that the slope of this equation then has to be negative 1, because that's what x is being multiplied. And then because b is 2, then the y-intercept has to be 0. Oops, I don't know what happened. Okay, oops. Okay, 0, comma 2 then has to be my y-intercept. And then on the right hand side, we give the graph of this line, negative x plus 2. You guys realize because my slope is negative, line falls. So whenever m is negative, whenever our slope is negative, then line has to fall. Okay? It has to go from left to right. It has to decrease. And then you guys realize because y-intercept is 0, comma 2, the line has to pass 2 on the y axis. So in general, there are different ways of representing and finding slope. So in mathematics, we generally say slope is the change in y over the change in x. And then if you're given 2 points, for instance, you can compute using 2 points. You can say, well, if I'm given x1 comma y1 and x2 comma y, if there are 2 points given on a line, then you can easily compute the slope doing y2 minus y1 over x2 minus x1. So the idea is you divide the rise by the run. And slope is one of the most important concepts in mathematics. It's so important for us to understand what it is. One tip that we offer here is that the order in which you use this formula matters. So for instance, if you do y2 minus y1, x2 minus x1, this is correct. You can also start with the first one, y1 minus y2, and x1 minus x2. This is also correct. But if you mix them, that's not correct. You can just do, on the top, you can just do y2 minus y1, and at the bottom, you do the first one minus the second one. This does not work. So this is incorrect. So you can either do y2 minus y1, x2 minus x1, or y1 minus y2, x1 minus x2. And you know, here we show some example why that matters. So you guys realize that we're gonna find the slope of a line passing through the points 3, 4, 5, 7. So we do, so this one's x1, oops, x1 and y1, x2, y2. So we put that in, so y2 minus y1 over x2 minus x1, and then you get 3 over 2. If we instead want to do something like y1 minus y2 over x1 minus x2, you guys realize we get negative 3 over negative 2, which is the same thing as 3 over 2. Here's an example. Find the slope of the line passing through negative 1, 2, 2, 2. All right, so we're going to apply the same formula. So x1, y1, x2, y2. So we're going to say slope is always y2 minus y1 over x2 minus x1. Or similarly, we can do y1 minus y2 over x1 minus x2. They're both the same. I decide to do this one. So I'm gonna say 2 minus 2 over x2 is 2, x1 is negative 1. So I'm gonna say 2 minus minus 1. So this will leave me 0 on the top and 2 plus 1 on the bottom, because minus minus will make it plus. So 0 over 3, which happens to be 0. So what that means is that this line will have this 0 slope, and then because it always passes through y, what that means is that the equation of this line is basically y equals 2. It doesn't have any slope. What that means is it has to be horizontal. So anytime we get m equals 0, we're going to say it has to be horizontal. And we're going to always realize that if any two y coordinates of a line are the same, then the line has to be horizontal. Next example, we have find the slope of the line passing through 3, 4, and then 3, 1. So we're gonna try to compute slope and see what's gonna happen. So m equals y2 minus y1 over x2 minus x1. Let's see what's gonna happen. Y2 is 1, y1 is 4, x2 is 3, x1 is 3. So you guys realize we get negative 3 over 0. So you guys realize we have 0 at the bottom. This is not good. This is alarming. We cannot have 0 in the denominator. This is not defined. Not defined. So what that means is that we do not have slope is not defined. We're gonna say slope is undefined. What that would mean is that this has to be a vertical line. And so because division by 0 is undefined, the slope is undefined, so the line has to be vertical. And then here's a tip: if any two x coordinates of a line are the same, then the line has to be vertical. We know that's true in this case because we have x equals 3, x equals 3. So for both of these guys have the same coordinate. All right, so next example, I want you to pause the video for a couple of minutes and you try to find the slope of this line passing through negative 2, 0 and 3, 1. So you try this and then continue watching the video. All right, so solution is gonna look like something like this. So we say m equals 1, 0 over 3 minus 2. So it'll be 1 over 3 plus 2, which is 1 over 5. So the slope has to be 1 over 5. So then we're gonna say this line passes through negative 2, 0, 3, 1, and its slope has to be 1 over 5. Okay. So next thing is we found the slope, but is it possible that we find the equation of this line? Because all we know is the slope. We know a couple of points, but we don't know if we could actually find the equation of this guy. So we know that generally speaking, all linear lines look like y equals mx plus b, right? This is what we call slope-intercept form. So general representation of linear equations. So because this line has the slope 1 over 5, I can represent this line using that slope. So I can say, because in this case m is 1 over 5, I can say 1 over 5x plus b. So it looks like my equation is almost complete, but I just don't have the b. I don't have the y-intercept, right? So if I had a way to find y-intercept, I would have gotten my whole equation. So then my next quest is going to be trying to find that b. Well, for that, what we do is we take a look at the points that we know. So these are the points that passes through the line. The line passes through these points. What that means is that these points has to be working on my equation. So these points should make this equation true. What that means is I can actually replace x's and y's in this equation using any of these points. It doesn't matter. So for convenience, I'm going to use -2, 0. But you could also use the other one. It'll be the same thing. So what I'm going to do, I'm going to replace y with that point. So I'm going to say -2 equals 1/5 times x. So for x, I'm going to use, it's going to be the opposite. So y is 0, and then x is -2. And then I'm going to say plus b. So what that would lead me is that now b is basically being isolated. So b is the only unknown in this equation. So this will help me figure out what b actually is. So then what I will do is I will try to solve this for b. So I'll say 0, 0 equals -2/5 plus b. And then we're going to subtract -2/5 from both sides. Or add 2/5. So what that would mean is that then 2/5 will be equal to b. So what that means is b is 2/5. What it means is actually my y-intercept then has to be 0,2/5. So this is my y-intercept. Okay, and then let's complete our equation now. So then I'm gonna say this equation that I originally didn't know has to look like y equals 1/5x plus 2/5, because that is my y-intercept. So that is the equation of the line passing through those given points.